So dealing with Chatellier's principle, what we're going to be talking about here is the effects that you can have on equilibrium. So again, just to remind you, equilibrium, remember, the forward and reverse reactions are occurring at equal rates to one another. Therefore, there's no net change from your reactants into your products. So to kind of explain that, AB produces CD is happening at the same pace, okay, or rate as CD goes back to A plus B. So again, forward and reverse rates. So we're looking at Chatellier's principle. Really the big thing that we need to talk about is shifting. So the key idea here is there is a shift in a reversible reaction at equilibrium, means that one reaction, either the forward or reverse, is happening more than the other reaction, and the system is no longer at equilibrium, so you're causing a shift. So if you're shifting what we call right, so you're shifting for the forward, okay, so that means that you're favoring the amount of products, so the amount of reactants will actually end up decreasing, and your amount of products will actually end up increasing. If you have what's called a shift left, your reverse reaction is favored, therefore you're going to increase your amount of reactants, and you're going to decrease the amount of your products. So we're going to take a look at what are some ways or shifts that can occur. So Chatellier's principle basically talks about a system at equilibrium will shift to reduce any changes introduced to the system. So we have our forward and reverse. We want that our forward and reverse to be equal, and based off of that, how will we have a shift? So when we look at something like this, we want to talk about what is the actual effect of something being added to a system. So what can be added to cause a shift in a certain direction? So what was the effect on the system when the reactant is added? What's the effect on the system when the reactant is removed? So when we're looking at that, we're going to look at those shifts in particular. So when you add a substance, the system shifts away from whatever you added. So add away. So opposite of that is when you remove, okay, so the system will shift towards whatever you remove. So you have to think about, if I'm adding something, I'm going to create more of whatever that is, and if I remove something, then I need to make up more of what I removed. So I want you to do the sample problems on your own. Given the reaction below, predict whether the reaction will shift left or right or not at all. So if you increase the concentration of your H2, first you have to identify where your H2 is, so it's over here. Then I increase, so add away, so your reaction is going to shift in which direction. Decrease, okay, so we talked about remove towards remove, so now we're looking at our H2, in which direction is that going to shift. So looking at these sample problems, what I want you to take into consideration, again, is the things that we talked about. Add away, so the system will shift away from whatever you added, and remove towards. Really, when we look at concentrations, the other thing that we need to look at is just graphs in general, and this is something I kind of wanted to touch on and put some notes in here. How can we graphically show, and the Regents loves to show graphic questions and graph-related questions, especially when dealing with equilibrium. So you can see that I have reactant A and product B, and based off from these two lines, they're not at equilibrium because the concentrations are not constant. What we previously talked about is we're looking at those plateau regions. So based off from the plateau, you know they're at equilibrium because the concentrations are constant. They have a zero slope. However, if I add a stress, so in this case I added more reactant, so add away, what had to happen to my products? Well, we know that they had to reestablish equilibrium. So add away, I actually end up creating more product, and then to reestablish equilibrium after that, our second new equilibrium has been established. But since I added more A, I will in turn get also more B. Graphs make it much easier to kind of understand and describe equilibrium. Next process that we're going to talk about is what's called the Haber process, and that's going to be specific to a certain reaction and how we actually benefit as a society from this process in general.